In this video, we're going to take a look at some ratio, proportion, and percent questions and examples. And this is meant to be a preparation for the EQAO grade 9 math test in the province of Ontario in Canada. So there's a number of examples here that we're going to take a look at. And what I've done is I've gone through the last several EQAO years of math tests, and I've pulled out questions and tried to make examples that are very, very similar to those questions. And in the grade 9 math course, there's a strand on number sense and algebra. So I broke that down into two parts. So I'm going to do a ratio, proportion, percent video, and separately I'm going to do an algebra and solving equations video. So I've broken down into those two parts, that one strand. So this first part here, a ratio compares two or more quantities. For example, a fertilizer is labeled 16-4-8, which means that it's 16% nitrogen, 4% phosphorus, and 8% potassium. And actually, so those numbers are all percentages. If you forget the order, but you know what the nitrogen, phosphorus, and potassium are, they're actually in alphabetical order. N is before P, and PH would be before PO. Another example, the profits of a business are split between Sharon, John, and Sam in the ratio 5:3:1. So the next couple of examples deal with those two situations. So in the first one, we have this same fertilizer, and we're asked to determine the mass of nitrogen in a 40 kilogram bag of fertilizer. So to find the mass of the nitrogen, the bag is 16% nitrogen, so we're really finding 16% of 40. And 16 as a percent is 0.16. Divide that by 100, or move the decimal from here to 2 places, so it's 0.16. So 0.16 times 40 is 6.4. So there'd be 6.4 kilograms of nitrogen in that 40 kilogram bag. So in B here, we're told instead that this wheelbarrow has a certain amount of fertilizer in it, and 5.6 kilograms of it is phosphorus. So we're asked then how much nitrogen would it have in that wheelbarrow. So remember the ratio up here, and we don't need the 8 because the question has nothing to do with potassium. So we're really only dealing with the nitrogen and the phosphorus, so we only need the 16 and the 4. So the ratio of nitrogen to phosphorus is 16:4, and so we're told there's actually 5.6 kilogram of phosphorus. Notice that the phosphorus is the second number in the ratio, so it's the second number in the ratio over here. This is the ratio of the two things. This is going to be the actual masses, which have to be in the same ratio. So 5.6 goes second, and N represents the amount of nitrogen. Now there's more than one way to solve this. I'm going to show you a couple, actually 3 altogether. So one way is to write it as a set of two equal fractions, or a proportion. And so I could write 16:4, this to this is the same as this to this. So 16:4 equals N over 5.6. If those ratios are equal, then these two fractions would be equal. And so we can cross multiply. So to get N, we multiply 6 by 5.6 and divide it by 4. And so that looks like this. And actually, you will see some people solve this slightly differently. To do the cross multiplying, they multiply this by this. So that would be 4n. And that would equal the product on this diagonal, the 16 and the 5.6 here. And I want to show you that this is exactly the same as what I wrote a moment ago. So in that, to isolate the n, we would divide out the 4. And so if you do that, then notice it's exactly the same calculation. So if you evaluate that, you will get 22.4 kilograms. Now, this is our set of two equal ratios here. So instead of writing 16/4 equals N over 5.6, you can also write 16, and I'll write it over here, the first number over the first number, 16 over n, equals the second number over the second number. And so notice when I do the cross multiplying, I'm still multiplying 6 by 5.6, or sorry, 16 by 5.6 and dividing by 4. So it works out to the same thing. One last way you could do this is you could notice, and this is especially convenient if the numbers work out nicely like they do here. There's a multiplying factor by 4 here. If you multiply the phosphorus by 4, you get the nitrogen amount. So if you multiply the 5.6 by 4, you will get the actual nitrogen amount, which works out to this 22.4 kilograms. So lots of ways to solve that. On to the second page, and so here's the example with the business one. The profits of business are split between Sharon, John, and Sam in the ratio 5 to 3 to 1. And this kind of thing is often done if you have a business where not everybody contributes the same amount. If everybody contributed the same amount, then they probably would all get the same amount of income from the business. But if you can contribute different amounts, the larger amount you contribute, generally the larger amount you get to collect. So basically it means that for every $1 that Sam gets, John gets 3 and Sharon gets 5. So this is the ratio of their sharings. And so, for example, 5, 3, and 1 add to 9. So if the company made $9, then Sam would get 1, John would get 3, and Sharon would get 5. If instead of $9, if we doubled it all, it made $18, then Sam would get 2, John would get $6, and Sharon would get 10. Those numbers are in the same ratio because I just multiplied them all by 2, so that they add up to, instead of 9 like this does, they add up to 18 here. So now, of course, those amount of earnings are pretty small for a business. We're talking about a business that made $115,000. So what we're going to do is we're going to we want to find out what number I multiply this ratio by, so these 3 larger numbers still add up to 115,000. So I'm going to call that number K. I'm going to multiply each of these by K, so the 5 becomes 5K, the 3 becomes 3K, and the 1 becomes just 1K, or just K. And so I'm going to solve this equation. The 5K and the 3K and the 1K have to add up to that $115,000 that the business made. So if we add 5K and 3K, that's 8K, plus 1 more K is 9K, so this simplifies to 9K equals 115,000. And we divided the 9, and so K is $12,777.78. So it's money, that's why I'm rounding to 2 decimal places. So that's the number that we multiply each of these by to get the earnings, actual earnings for Sharon, John, and Sam. So Sharon's share would be 5 times this number, and so that works out to $63,888.90. For John's share, we'll multiply the 3 by this 12,777.78 number. And so he's going to get $38,333.34. And Sam's share is just 1 times that, so it's going to be $12,777.78. Now, so that's how you do this. Now, if you were the accountant for this company, you really want all of those numbers to add exactly to 115,000. So I have a couple of screenshots here I want to show you. If I actually add these actual numbers, notice it adds to 115,002 cents. And if you're the accountant, that's not okay. It's got to work out to exactly 115,000. So all we have to do is actually take a few more decimal places here and redo the calculation, and we'll get the amounts to add up exactly to $115,000. So we divide 115,000 by 9 here. So here's and so this gives us more decimal places. It's just 0.7 repeating. And so what I did in my calculator is I stored that number in a memory called A. And so Sharon has 5 times that value, John has 3 times that value, and Sam's going to get that value. So if I do 5 times that whole decimal, not doing any rounding at all, it's 63888 and 88, well, 8 repeating. So this would actually round to 89 cents. So instead of 90, she should get 89 cents. John's is going to be 33, not 34. And Sam will get the $112,777.78. So his was actually okay. So basically, Sharon and John need to get 1 penny less, and it adds up to exactly to the right amount. And there's the verification there. Those are the 3 numbers added. It works out to exactly 115,000. No pennies to worry about. Now, I want to show you an alternate solution for this before we get into another kind of question. So same question, exactly the same question. And so here's an alternate solution. Notice that the numbers in the ratio 5, 3, and 1 add to 9. And so that means that Sharon actually gets 5/9 of the profits, John gets 3/9 of the profits, and Sam gets 1/9 of the profit. Now, I would simplify this. This is the one fraction here that actually simplifies. 3/9 reduces to 1/3. So he's actually getting 1/3. Now, if we divide 5 by 9, we get this 0.5 repeating number, and the same with John. I'm keeping several dozen places so I have my accuracy. I don't worry about that penny thing in the last example. So, like if somebody asked you what percentage does Sharon get, you could say it's about 55.6%, John gets 33.3%, and Sam gets 11.1%. And so, if you take the 115,000 now and multiply it by these decimals, there's Sharon's earnings. Here's John's earnings and Sam's earnings. And so notice that here's my screenshot from the last page, just verifying that all these are correct to the penny. I kept a lot of decimal places here, so I got them to round the way they're supposed to in this time. So that's a little different way to do that. You can actually figure out what fraction of the or percent of the profits each one gets, and it's another way to solve it. So here's another ratio, proportion, percent kind of question. Betty's mixing a juice blend. She mixes 3 parts apple juice with 4 parts peach juice. We're asked how much of each should she mix to fill a 2-liter jug. Notice that the parts aren't the same. If they were both the same, a 2-liter jug, we would just put a liter of each in, but they're not the same. So the ratio of apple juice to peach juice is in the ratio 3 to 4. That's what the question tells us. 3 parts apple to 4 parts peach. So I'm doing apple first, so the 3 goes first, and the peach is second. That's the 4. So I really want to know what I multiply these numbers by, so the two numbers add to 2 liters. And so I'm going to multiply them both by K, very similar to the previous examples. So I would solve this equation. 3K plus 4K adds to 2. Or if you want, okay, so that's going to give us answers in liters. If you want to do milliliters, remember 2 liters, there's 1,000 milliliters in 1 liter. So if you want to rate the 2 liters as 2,000 milliliters, then that works fine too. That will give you answers in milliliters, which is probably a more manageable unit, but it's up to you. You just have to remember this is going to be in liters. This is the one I'm going to solve. So 3K and 4K add to 7K, and then we divide out the 7 to isolate for K, and we get 2/7. And keep several decimal places. When I divide 2 by 7, I get 0.2857. So I kept 4 decimal places here. So that's the number that we multiply the 3 and the 4 by to get 2 numbers that will add to exactly 2 liters. And so my apple juice, I do 3 times that. So the apple juice amount is 0.8571 liters. And the peach juice, we would multiply this number by 4 because the peach was the 4 number in the ratio, which is 1.1428. And so Betty should mix, so I'll put my answer statement down here and then talk about it for a moment. So Betty should mix, and I rounded a little bit. You don't really need the 4 decimal places when you're telling Betty how many liters or milliliters to use. So I rounded to 0.86, so about 0.86 liters or 860 milliliters of apple juice, and 1.14 round this to 2 decimal places too, or about 1,140 milliliters of juice. This is liters, that would be milliliters. Okay, now a little bit more about percent here. We've dealt percent some, but remember that percent means out of 100. So for example, if I was dealing with the number 15%, then that's the same as 15 out of 100. And when you divide 50 by 100, that's how you convert that into a decimal. So you normally, in most calculations, you need the decimal equivalent, not the actual percent number. So it's 0.15. Another example, let's say you had 20.5%. Now, what you really, the decimal as a percent is right here. You're really moving it 2 places. So that's why it's 0.15. So if I divide this by 100, I'm really going to move that 2 places, so it's going to be decimal 2075. So that's a quick way to change a percent into a decimal. Move the decimal 2 places to the left. So in this example here, Kaleem wishes to buy a pair of runners. He selects a pair that were listed at $149.99, but they're marked down 20% since they were last year's stock. In addition, today there is a sale giving an additional 15% off. And you're asked, what is the purchase price including 13% GST? So that's the tax. So we've got two different discounts here. Now, you cannot add the 20 and the 15 and say it's 35% off, because the discounts generally are done one at a time. So after you've taken 20% off of $149.99, the purchase price is going to be smaller, and then the 15% comes off of that. So you do have to do them one at a time. So I'm going to show you a way to organize this, and this is often kind of the thing you'd see on a receipt. So, or if somebody in the store actually wrote it out to show you what the discounts are, how you get the final price, etc. So we're starting at $149.99, and we're going to take 20% off of that. So the calculation to get the actual amount for the 20% discount, we take that original price and multiply it by 0.20. That's 0.20 is 20%. And so that gives us a discount amount of $30. So that's going to be subtracted from the $149.99. So if we subtract that, the purchase price with the 20% off is $119.99. So this is the amount we're going to find 15% of to take this second discount off. So we need to, now the 15% discount, so 0.15, the decimal equivalent of 15%, is multiplied by the $119.99. So notice that it's not multiplied by the original amount, it's multiplied by this new price. And so that gives us another discount of another $18 off. So here's the 15% discount. So we're going to take $18 off the $119.99. So we're going to subtract those. And so we could call this the fully discounted or before tax price. So if we subtract those, we get $101.99. So to calculate the tax at 13%, 13% of this 101.99 is 101.99 times 0.13, which works out to $13.26. So we're going to now, not sure why that came in separately. So the tax gets added on. It's not a discount. We're going to, because that's the amount the store is going to give back to the government. So we're going to add $13.26 to 101.99. And so the net or final price the customer pays, Kaleem pays, we add these and we get $115.25. So that's the final price after the two discounts and adding on the tax. A little bit more about percent. To determine what percent one number is of another number, it's always a good idea to write as a fraction first. You're told some kind of ratio or between two quantities, write as a fraction. And I'm going to show you that through the next few examples. And I'm going to use baseball for this one. So Etienne plays baseball, and we're told in 53 trips to the plate, they're called at-bats if you know much about baseball. So an at-bat is when you go up to the plate and you get to swing the bat to try to hit the ball. He gets 14 hits, so he actually hits the ball 14 times out of 53 trips to the plate. So the question is, what percentage of the time does Etienne get a hit? Which is really the same thing as calculating what's called his batting average. Now, his ratio of hits to at-bats is 14 to 53. 14 times he actually hit the ball in 53 attempts to hit the ball. So the fraction is 14 over 53. So 14 53rds of the time he got a hit. So if you divide 14 by 53, and this is what it looks on my graphing calculator do, 14 divided by 53 is 0.26415, etc. And so I'm rounding well, I'm changing it to a percent, and I'll round it to one decimal place. So to convert that back into a percent, you would move the decimal 2 places. So that's why it's 26.4%. And so that is the percentage of the time he got a hit. Now, a little bit about that. If you know anything about baseball, they'll often write it like this. If you look at baseball stats at all, they'll actually leave it like that. And they actually call it the batting average. So, and the words they'll use to represent that, they'll call it a 264 batting average, which means it's a 0.264 decimal, or 26.4%. So that's a 264 batting average. In this seventh example, in another season, Etienne's batting percentage is 30.8%. So as a batting average like this, it would be 0.308 or a 308 batting average. That's how it would actually be said. So the question is, if he goes to the plate 185 times, he got a lot more at-bats this season, how many hits does he get? Well, the number of hits he gets should be 30.8% of the number of times he tried to hit the ball, he went to the plate. So we're asked to find here 30 point, that's what the wording would mean. We're asked to find 30.8% of the 185. So to find a percentage of a number, you multiply the percent as a decimal by that number. So the 30.8% would be 0.308, how you'd actually write the batting average, times the 185 at-bats or trips to the plate that he had. So if we multiply that, we get 56.98. And of course, you can't get a part of a hit, so we would round that to 57. He got about 57 hits that season. And one last page here, and one more example. So sometimes we want to find that out of number, like the in this case, like the 185 at bats or trips to the plate. So there's really three numbers you could find, and the first two examples dealt with finding the batting average and the number of hits. So now I'm going to show you in this last one how you'd find the out of number, like the 185 at bats that he had. So, and a little bit of explanation before we get into the last example, because that's what's asking. So in the example for number 7 on the previous page, it'd be like knowing the 0.308 or 38%, and the 56.98, and finding the 185 number, the number of hits. Now remember, this is how you calculate batting average. We took the number of hits and we divided it by the number of at-bats. So it's really like we know this guy here, and we know this guy here, and we're trying to find this denominator, which is the 185. So I'm going to work with numbers that you know from the previous page, so hopefully it'll make more sense. So if we fill in the values, the 0.308 and 56.98, so it's like we're pretending we don't know the 185. I'm showing you how to get it here. So when you cross multiply, remember this multiplied by this would equal the 56.98. If you know much about cross multiplying, and just a second, it's really like there's a 1 underneath this. So 0.308 times 185 should equal 1 times the 56.98. So that's why I'm writing this like this. The 0.308 times the 185 equals the 56.98. So it's kind of like we don't know this, okay, if we didn't know the 185. So I'm going to call that A, which stands for at-bats. So it's kind of like if we know the batting average and we know the number of hits he got, how would we find that? Well, in this little linear equation, the A and the 0.308 are multiplied. So to undo multiplying, we divide out the 0.308, both sides. So this divides out. And so if we divide 56.98 by 0.308, that's how you get the 185. So you're using dividing to get the out of number. I'll call it the out of number. So for example, the last example here, in the 2015 Major League Baseball season, Josh Donaldson, who was the American League MVP, he had a 297 batting average. And during the season, he actually had 184 hits, not to be confused with 185 here. So he actually hit the ball 184 times. So we're asked, how many at-bats or trips to the plate did he have? So remember, batting average is hits divided by at-bats. So try to write out the ratio formula here and fill in what you know. So the number of hits is 184, and we're trying to find how many at-bats he had, and we're told that this batting average is 0.297. Now, again, you can think of the 0.297 as 0.297 over 1. And so we'll cross multiply. And so to get A, we multiply the 1 by the 184 and divide by the third number, the 0.297. So 1 times 184, which is 184, divided by 0.297 gives us that number, that bat number. So it's 619.5, which would round to 620. So we had 620 at bats during that season. And so that's the last example. And what I'm well, I'm going to do it very shortly here. So by the time you watch this video, it should be there. I'm making up these videos for all the strands in the grade 9 course. I've actually got 3 of them done. I'm going to get 3 of them uploaded this afternoon. Other resources you'll find links in the description are to some practice questions for these, and also a document that has answers that go over these. I hope eventually to have videos that goes over all the answer solutions. I don't have that done yet, but hopefully eventually I will get to that. So look for those documents, and if you happen to try to get them and the link doesn't work, let me know, please. Thanks.